Hi everyone, once again welcome to my channel Quantitative Maths by Biology. Yes, we are in the chapter comparing quantities using proportion, and today we are going to look part 3 of comparing quantity using proportion. Yes, we have a think, discuss and write. So first question of think, discuss and write. 2 times a number is 100% increase in the number. If we take half the number, what would be the decrease in percent? Solution. Let the original number be is x. If the original number be x, then consider 2 times the number. 2 times the original number is equal to 2x. Let us prove if the number is increases to 2x, the increment is 100% or not. That is, increment in the number is equal. So increased number is 2x minus original number x. Yes, it is equal to x. Original number is x and increment is x. So increase is 100% in the number. And also increment or decrement are often expressed as the percentage of original quantity. Yes, since increase or decrease are often expressed percentage of original quantity. Percentage of increase in the original number is equal to increment is x over original number is also x. Since increment or decrement are often expressed as percentage of original quantity, so denominator is original quantity into 100%. Since we have to find percentage of increase, so we have to multiply with 100%. X by x 1 into 100%, 100%. Yes, 2 times a number is 100% increase in the number. If we take half the number, now consider half the number. Original number is x, half the original number is x by 2. Then find decrement. Decrement is equal original number x minus decrease new number, that is x by 2. X minus x by 2, 2 into x, 2x minus x, again x by 2. Decrement is x by 2. So decrement or decrease percent equal decrement is x by 2 over original number is x into 100%, which is x by 2x into 100%. X gets cancelled. 100% over 2, that is equal to 50%. Yes, decrease percent is 50%. So that is, if we take half the number, the decrease percent is 50%. Okay. Next question. Important one. By what percent is rupees 2000 less than rupees 2400? Is it the same as the percent by which rupee 2400 is more than the 2000? Let us see. Solution. We have to find what percent is rupees 2000 less than 2400. In the question we have two cases. First one is what percent rupee 3000 less than the 2400. Second case is by which rupee 2400 is more than 2000. Consider first case. Since we know that 2000 is less than 2400. 2000 is less than 2400. i.e., we say that 2400 is decreases to 2000. Suppose that. Then original number is taken as 2400 and new number is taken as 2000. Okay? Yes. 2400 is decreases to 2000. There is a decrement. So decrement is equal to difference of 2400 and 2000, that is 400. Let us find decrement or decrease percent. Since we know that increase or decrease are often expressed as percentage of original quantity. So decrement is 400 over, we have to take, they are expressed in the percentage of original quantity. Original number is 2400 into 100%. Since we have to express it in percentage form, so we multiply 400. 2 zeros, 2 zeros, 4 ones are 4 six are 2 threes are 2 50s are 50% over 3. We know that 3 16s are 48, 2 remainder over 3. That is 16 whole 2 by 3%. If we divide 50 with 3, we get quotient as 16, remainder as 2, divisor as 3. That is equal to 16 whole 2 by 3%. That is 2000 is 16 whole 2 by 3% less than 2400. Consider case 2. By which rupees 2400 is more than rupee 2000. We know that 2400 is greater than 2000. In this case, suppose we let 2000 is increased to 2400. So here we take original number. Original number is taken as 2000 and new number is taken as 2400. Since 2000 is increased to 2400, there is an increment. That increment is equal to difference of 2400 and 2000, that is 400. So increase or increment percent. Since increase are often expressed with percentage of original quantity, so increment is 400 over original quantity 2000 into 100%. 1 2 3 1 2 3 zeros cut, 40 by 2, that is 20%. Yes, that is 2400 is 20% more than 2000. In the question, 2000 is 16 whole 2 by 3% less than 2400. 2400 is 20% more than 2000. So he asked, is it the same? Obviously, they are not same. They are not same. Okay, students. In the first case, we compare 2000 to 2400. In the second case, we compare 2400 to 2000. Okay. Next, solutions of questions of exercise 5.1. First question, find the ratio of the following. First one of first bit. Smita works for 6 hours and Kajal works for 8 hours in her office. Find the ratio of their working hours. Solution. Number of working hours of Smita is 6 hours, and that of number of working hours of Kajal is equal to what? 8 hours. Therefore, we have to find the ratio of their working hours. Therefore, required ratio is equal to number of working hours of Smita is number of working hours for Kajal. Hours gets cancelled. 2 3s are, 2 4s are. So required ratio is 3:4. Second one. One pot contains 8 liter of milk while other contains 750 milliliter. Yes. Here units are liters, here units are milliliter. But we compare two quantities of same kind. That means they must have same units. So we have to change liters into milliliters. We know that 1 liter equaled 1000 milliliters, that is ml. So 8 liters equaled 8000 ml. Therefore, a required ratio is equal to the milk in the first pot, that is 8000 milliliter, is milk in the other pot, that is 750 milliliter. Yes, units are same, so that we can compare these two quantities. ml 0 0 gets cut. 25 3s are 25, 32s are 800. That is 32:3. Okay. Third one. Solution. Speed of cycle is 15 km per hour. Speed of scooter is 30 km per hour. See, the units are same, so we can compare simply. That is, speed of cycle is given by 15 km per hour and speed of scooter is 30 km per hour. 30 km per hour. So, ratio of their speeds, that is required ratio. Speed of cycle is speed of scooter. Units are gets cancelled. 15 ones, 15 twos. That is 1:2. Next question. Second one. If the compound ratio of 5:8 and 3:7 is 45:x, find the value of x. Solution. The compound ratio of 5:8 and 3:7 is equal to, what is compound ratio? By the definition of compound ratio of two ratios is a ratio of product of antecedents 5 3s are 15 is to product of their consequence 8 7s are 56. Yes, compound ratio of these two ratio is product of their antecedents is to product of their consequence. But according to question, their compound ratio is given that 45:x. Therefore, according to the question, according to the question, 15:56 is the actual compound ratio of these two ratio. In the question it is given that 45:x. So both are equal. That is 15:56 is proportional to 45:x. Since these two ratios are equal, these four terms are in proportion. When four numbers are in proportion, then we know that product of extremes equal product of middles. That is 15 into x is equal to 56 into 45. 15 ones are 15 threes are 45. 1 times of x is x. 56 into 3. 3 50s are 150. 3 6 are 18. So it is 150 plus 18, 168. So x value is what? 168. Second question. The compound ratio of 7:5 and 8:x is 84:60. Then find the value of x. That is the compound ratio of 7:5 and 8:x is product of their antecedents. 7 8s are 56 is to product of their consequence. 5 into x, 5x. According to question, their compound ratio is equal to 84:60. Therefore, 56:5x ratio will be equal to 84:60. That is equality of two ratios, nothing but these four numbers are in proportion. Therefore, we know that if four numbers are in proportion, product of extremes equal product of means. 56 into 60 is equal product of means, that is 5x into 84. 5 ones, 5 12s are 60. 12 ones, 12 sevens are 84. 7 ones, 7 8s are 56. 8 into 1, that is 8 equal x into 1 x. So the value of x is what? 8. Okay. Third question, important one. The compound ratio of 3:4 and the inverse ratio of 4:5 is 45:x. Compound ratio of the ratio 3:4 and the inverse ratio of 4:5 is 45:x. Then we have to find x. First of all, we have to find inverse ratio of 4:5. That is inverse ratio of 4:5 is equal to what? Just 5:4. Just exchange the antecedent and consequent. That is inverse of the given ratio. Now, the compound ratio of the ratio 3:4 and inverse ratio of 4:5, that is 5:4, is equal. Compound ratio of these two ratios is product of their antecedents. 3 5s are 15 is product of their consequence. 4 4s are 16. But according to question, their compound ratio 15:16 is equal to 45:x. 45:x. That means equality of two ratios. Therefore, we know that product of extremes equal product of means. Product of extremes, that is 15 into x equal product of means 16 into 45. 15 ones, 15 threes. X equal 16 threes are 48. Okay. Next last two questions of part 3. Fifth one. In a primary school, there shall be 3 teachers to 60 students. If there are 400 students enrolled in the school, how many teachers should be there in the school in the same ratio? Let us see it by two methods. First one is unitary method. For 60 students, 3 teachers are appointed. Yes. For 60 students, 3 teachers are appointed. So we have to find for one student, to get one we have to multiply 60 by 60. So here also we have to multiply 3 by 60 teachers are appointed. But we have to find number of teachers appointed for 400 students in the same ratio. That is, for 400 students, number of teachers are appointed into 3 by 60 into 400. To get 400, we have to multiply 1 by 400. In a similar manner, we have to multiply 400 here also. Teachers are appointed. 0, 0, 3 ones, 3 twos, 2 ones, 2 20s. That is, for 400 students, 20 teachers are appointed. 20 teachers are appointed. Okay. Let us see it by method 2 called proportion method. Number of teachers for 60 students is equal to 3. Let number of teachers for 400 students be x. Ratio of students is initial students are 60, final students are 400, and that of ratio of teachers are 3:x. Therefore, ratio of students is proportional to ratio of teachers. That is, 60:400 is equal to 3:x. We know that product of extremes equal product of means. 60 into x is equal to 400 into 3. 0, 0, 3 ones are 3 twos are 2 ones are 2 20s are. X equal to what? 20. Therefore, number of teachers appointed for 400 students is 20. Next question. In the given figure, ABC is a triangle. Write all possible ratios by taking measures of sides pairwise. Solution. For triangle ABC, we have 3 sides. That is AB, BC, CA. And we have to find all possible ratios of measures of sides pairwise. Consider ratio of AB is to BC. Ratio of side AB to BC. AB length is 8 cm is to BC length is 6 cm. centimeter, centimeter, 2 4s, 2 3s, which is equal to 4:3. Similarly, AB is to AC. Consider AB is to AC. AB length is 8 centimeter. AC length is 10 centimeter. Centimeter, centimeter, 2 4s, 2 5s, which is equal to 4:5. Similarly, BC is to AC. BC length is 6 centimeter, AC length is 10 centimeter. 2 3s, 2 5s, so ratio is 3:5. And consider inverse ratio of AB is to BC, that is BC is to AB. That is inverse ratio of AB is to BC. So BC length is 6 centimeter, AB length is 8 centimeter, which is equal to 3s to 4s, 3:4. Yes, 3:4 is the inverse ratio of 4:3. Similarly, consider the inverse ratio of AC is to AB. AC is to AB. AC is 10 centimeter, AB is 8 centimeter. 2 5s, 2 4s, that is 5:4. Similarly, consider the inverse ratio of BC is to AC, that is AC is to BC. AC is 10 centimeter, BC is 6 centimeter, which is equal to 5:3. These are the possible ratios of sides pairwise in triangle ABC. Okay students, this completes the part 3 of comparison of quantities using proportion. Okay, thank you. Have a nice day.